Hello guys, today we will discuss about biostatistics hypothesis testing. Okay, so the first question we will start with the F test. Okay, so F test is used to test the significance of differences among. So there are several options given. So I would like to discuss first some basic topics before going in detail into this question. So the first thing is what is hypothesis testing? What is hypothesis testing? So hypothesis testing, it is a way to find out that the results or a survey of an experiment are meaningful. Okay, that the survey what we are doing or the experiment or the hypothesis which we are doing is true, okay, or they are meaningful or they are true and dependent or not. So true or not, dependent or not. Okay, and this there is one hypothesis and then there is alternate hypothesis. So two hypothesis term are there. One is null hypothesis and another is alternate hypothesis. And what is this alternate hypothesis? Alternate hypothesis assumes that there is some difference between the true mean and the there is the difference between true mean and comparison value with whatever the value we are comparing with, okay, with the control group and the experimental group. Okay, comparison value. Okay, and the null hypothesis, what does it states? That there is no difference between the mean and the comparison value. So this is about the this is about the hypothesis where two hypotheses are taken, null hypothesis and the alternate hypothesis. So I'm not writing here in detail, I'm just writing here name null hypothesis, which is denoted by H0, and HA is alternate hypothesis. Next we come to F test. So what is F test? So it is a statistical test in which the test statistic, has an F distribution under null hypothesis. So sounds complicated, right? So F test of overall significance, what does it indicate? It indicates whether your linear regression model provides better fit to the data than a model that contains no independent variable. So I make it more simpler. ANOVA is a way to find out if a survey on an experiment results are significant or not. So here ANOVA is used and ANOVA uses F test. Okay, ANOVA uses an F test to determine whether the variability between two or more sample means is larger than the variability of the observation within the group. So ANOVA uses an F test. It helps to determine whether the variability between more than two sample means is larger than the variability of observations within the group. So variability of observations within the group, whether this is larger than the variability between more than two sample means. So this is the where ANOVA uses the F test. So F test uses two sample variants which are S1 and S2. So S1 and S2 are the two sample variants and S1, S2 are used by dividing with each other. Okay, they by dividing them, and the value is always positive because the variance is positive. Variances are always positive, I write here. And the equation is represented by S1 square by S2 square, where S is equals to sample variance. Okay, so coming to the question now. F test is used to test the significance of the difference between or among. It will be more than two sample means. Okay, it will be more than two sample means. This one, and variance of two sample means. Just now we discussed. Question number 2 is arrange the following steps in the process of hypothesis testing in proper sequence. Okay, so let's again discuss in detail first of all. So, what steps do we follow while testing a hypothesis? So, the first step is what? So, first step is set up a null hypothesis and alternate hypothesis. This is the first step. Whether there is a difference between there, whether there is difference from the mean or not different from the mean. Okay. Then select the significance level. Select the significance level which is at alpha is equals to 95% or 95.9%. Then third is select test statistics. Fourth is establish the decision rule. Okay, establish the decision rule. Fifth is performance computation, and the last one is draw conclusion. Okay, so I repeat again. First is set up null hypothesis and alternate hypothesis. Then second is select the significance level. Third is select test statistics. Fourth is performance computation, and fourth is establish the decision rule. Fifth is performance computation, and sixth is draw conclusion. Okay. So hypothesis testing, it's a kind of formal process for examining the theories about the world. Okay. So let's move forward to the next question. Next question is which test we normally apply for qualitative data? This is a very important question. Let's discuss this in detail. First of all, what is qualitative data? Qualitative testing. So qualitative testing of data is about understanding the cognitive process of the participants. Cognitive process of participants, that is, it is about understanding the interaction effects, like for example their overall emotions, expectations, studying interaction effects. Okay, so these all are included in qualitative testing. Now coming to the next, under qualitative testing, what are included? It is chi-square test, which is represented by a symbol chi. So I write here chi-square test. So chi-square test is what? It is a statistical test. It is a statistical hypothesis which compares two variables to check how they are related, to know how variables are related. How two variables are related. Okay, so this kind of test, chi-square test, it's a non-parametric test. It's a non-parametric test. It's a non-parametric test, and it is normally applied to qualitative data. So there are two types of chi-square test. Chi-square have two types. The one is chi-square goodness of fit. Chi-square goodness of fit, and the second is chi-square test for independence, which is, so I'm writing here the symbol chi-square test for independence. So two chi-square tests are there which are important for qualitative data analysis. So starting with what they are, number one, goodness of fit. So chi-square goodness of fit, what it does, I'm just writing goodness of fit instead of chi-square goodness of fit. What it does, here it determines if sample data matches with the population. If sample data matches with the population. And what about the chi-square test for independence? So what it does, it tests whether the distribution of categorical variables differ from each other. Whether distribution of categorical variables differ from each other. We will discuss about it more when we will solve more questions. Variables are different from each other. So variables are related or not, like age is related to the hunger or not, age is related to the illness or not, are they independent or not, and goodness of it if the sample data matches with the population. So whether distribution of categorical variables are different from each other. Okay, so chi-square test is normally used to test the qualitative data. So other test also I would like to explain you, that is t-test. So what is t-test? It is used to compare the means of two groups. Okay, it will compare the means of two groups, and this is also a hypothesis testing. It is used to find out whether a process actually has an effect on the population or not. Okay, whether a process, it's a very common test. We all are familiar with it, I think. Whether a process actually has an effect on the population or not. Okay, and whether the groups are different from one another. Okay, whether the groups which are we are considering are different from one another or not. Okay, and the test is necessary for small sample size. Here the sample size is small. How much small? Must be less than 30. Whether where distributions are not normal. Okay, so it is necessary to have the sample size n is not n less than 30. Okay, so the next test is F test. F test already discussed. Again, some key points I would like to say. So F test uses two sample variants S1 and S2, and the formula is S1 square by S2 square. Okay, S stands for variance. Okay, next we come to Z test. What is Z test? So the statistical technique which is used to determine whether the two population are different from each other or not. So whether the two populations, here the population term is there, populations are different from one another or not. Okay, when variants are known. So in Z test, variance is known to us because when you will see the formula of Z test, the variance is there in the formula, without which you cannot find out the value of Z. Okay, when variance is known. Okay, so whether the two population are different from one another or not, when variance is known, and this test is used to test the hypothesis which follows normal distribution. So when normal distribution curve, if you know, it's a bell shaped curve. It's like this. Okay. So here I am rubbing it. So when the data follows normal distribution, then this type of Z test can be used. And when the sample size is greater than 30, okay, n greater than 30, then a Z test will be used. Okay. Moving forward. So I repeat here, which test we normally apply for qualitative data? It's chi-square test. Okay. Others are generally for the quantitative data. Next question is, goodness of fit for a distribution is tested by. Just now we have discussed the goodness of fit is tested by chi-square test. Again, let's discuss some points in detail. Since the options are there for t-test, f-test and z-test, let's discuss it once again. So t-test tells us about how significant the difference between the two groups are. So it compares the means of the two groups and tells how significant is the difference. Okay, it's a kind of hypothesis testing only, and the t-test is used for the purpose of hypothesis testing, and it tells us about what, whether a process actually has an effect or not, whether the groups are different from one another or not, and if they are different, then how significant is the difference. Okay, next we come to f test. So f test already discussed, it's a ratio. F test is what? It is a ratio between two independent values, two independent variates, okay, that is divided by their respective degree of freedom. Two independent variates that is divided by their respective degree of freedom. Okay, and the f test follows f distribution. Okay, and all we discussed already. Also, one another point about f test is this f test tells us whether or not two independent samples have been drawn from a normal population, have been drawn from a normal population with the same variability, with the same variability, whether or not two independent samples have been drawn from a normal population, that is, samples drawn from a normal population having the same variability or not. Okay. Also, this F test is used by the researcher to determine whether the two independent estimates of the population variance, independent estimate of population variance are homogeneous in nature. Okay, so having the same variability or not, or they are homogeneous or not. Okay, and Z test we already discussed. Z test whether the population, uh, whether it's again a hypothesis test and it helps out from a test are valid or repeatable. Okay, and the sample size has to be greater than 30 and the sample must be normally distributed. And the last part is goodness of fit. This goodness of fit, it's a statistical hypothesis already said. It is used to see how well the sample data matches with the population. Or in other words, I can say that how if your sample data represents the data you expect to find in the actual population. Okay, whether whatever you are trying to find in the population is it representing the same or not. Okay, and there are multiple methods. There are multiple methods for finding out goodness of fit. What are the methods? Number one, it includes the chi-square. Number two, it includes Kolmogorov-Smirnov test. Number three, it includes the Anderson-Darling test. Anderson-Darling test. And the last one is Shapiro-Wilk test. Okay, and this goodness of fit, they are often used in business also in decision making in order to calculate the chi-square goodness of fit. So it is necessary to first state the null hypothesis. Okay, it's necessary to first state the null hypothesis and alternate hypothesis. Writing here in inverted commas. Okay, and choose a significance level. So these are important thing before performing the test. Okay, choose the significance level. Okay, and then determine the critical value before finding the conclusion. Okay, so these are about goodness of fit, and the most common goodness of fit is the chi-square. Most common is the chi-square, which is used into many business and also by researchers. Next question is King demand curve hypothesis was put forward by. So King demand curve hypothesis, it was put forward by Paul M. Sweezy. Next question is which one of the following statements relating to test of hypothesis are correct? Select the correct code. Statement 1 says type 1 error occurs when true null hypothesis gets rejected by the test. Statement 2 beta value denotes the power of the test. Statement 3 to test the significance of the goodness of a fit of distribution F test is applied. Statement it will be 4 when H0 that is null hypothesis and mu n greater than mu r. Okay, this is a kind of maybe a variable taken. Mu m greater than mu r, two-tailed test is applied for testing the hypothesis. Statement 5 says The critical value of Z statistics for the two-tailed test at 5% level is 1.96. So before going into the correct answer, let's discuss some points in detail. So first of all, what is hypothesis testing? I have already told about it when I was starting this class. So hypothesis testing is whether or not there is a difference between two sample distribution. So whether there is difference between two sample distribution, and if the difference between them is due to chance. Okay, whether there is difference, and if the difference exists, this may be attributed by chance, whether the distribution is by chance or not. Okay, so there are two possibilities of having two types of error. So two types of error can happen while doing the hypothesis testing. What are the two types of error that can happen? Number one is type 1 error. These are very important, you must know it. In my previous videos of biostats, I have discussed about the errors. You may go through that video and understand about it. I have solved some MCQ regarding that. So type 1 error and type 2 error. So what is type 1 error? So type 1 error is when true null hypothesis is rejected. When true null hypothesis, even when the null hypothesis is true, due to some error, this is rejected. When true null hypothesis is rejected. Okay, this is an error. When our null hypothesis was true, but still it was rejected due to some error. Okay, this shows error. Okay, and what about type 2 error? When the null hypothesis is false, it is accepted, or accepting the false null hypothesis. In short, in one straight line, I would write accepting false null hypothesis. Okay, so this is another kind of error. Okay, and when the rejection is on the both side of the sampling distribution, if this is a sampling distribution, and the rejection area is on both sides, here also and here also. Okay, so when the rejection area is on both sides, then what kind of distribution it is? It is called two-tailed test. Two-tailed test is what? When the rejection is on both the tails. These both sides, this is one tail and this is another tail. So when the rejection area is on both sides of the sample distribution. This is known as two-tailed test. So this is where our sample mean lies, and this is area where sample distribution lies. Okay, so this is the two-tailed test. And when the rejection lies only in one side, then it is one-tailed test. This may be right side or left side, only in one side, then it is one-tailed test. Okay, another important point I would like to discuss, level of significance. So what is level of significance? It is a probability. It is probability of rejecting when null hypothesis is true. So probability of rejecting the null hypothesis when it is true. So how much probability is there that you have rejected the null hypothesis when it was true? That is called probability or level of significance. Okay, so critical value of Z statistics for a two-tailed test. So a critical value of Z statistic of two-tailed test. Remember, I am mentioning here two-tailed and Z statistic at 5% level of significance is 1.96. Z value is 1.96. Here, what is being asked is Z statistic value. Okay, so let's go to the question now. So here the question says which one are correct. Statement 1 says type 1 error occurs when null hypothesis gets rejected even when it is true. Okay, so this is correct. 1 is correct. Beta value denotes the power of the test. It is wrong. 1 minus beta value denotes the power of the test. Okay, this is wrong. Statement 3, to test the significance of the goodness of fit of a distribution, F test is applied. So we all know now chi-square test is applied. Question 5, sorry 4. When H0 greater than H0, when mu m is greater than mu r, so two tail test is applied. So here we see here that only one tail test will be there because arrow is on the one side. Okay, so if two values are there, then we can say it can be either less than something or greater than something, greater than one value or less than some value. Then it will be two-tailed test. But here just one comparison is shown where the value lies on one side, that is towards m only. So this is one-tailed test. Next is the critical, this is wrong. Next is the critical value of Z statistics for two-tailed test at 5% level of significance is 1 by 1.96. If you see the Z table chart, you will find out that at 5% level and at two-tailed test, the Z value is 1.96. So 1 and 5 are correct. That is, type 1 error occurs when the null hypothesis get rejected, and 5 is the Z value at two-tailed test. For two-tailed test at 5% level is 1.96. Okay. Next question is which one of the following statement is true in the context of testing of hypothesis? It is only the alternate hypothesis that can be tested, so it is false. Null hypothesis is also tested. Sorry, uh, which one is true? So it's a null hypothesis which is tested. There is not the alternative hypothesis which is tested. Okay. Question number 2 is it is only the null hypothesis that can be tested. So this is true. Both the alternative and null hypothesis can be tested. False. Both the alternative and null hypothesis cannot be tested. This is also false. So let's go into the detail of this one. So null and alternate hypothesis. Okay. So, null hypothesis is what? Null hypothesis states that there is no association between the two variables. Okay, and H0 is denoting the null hypothesis. And say, for example, there is no effect between the persons kind of doing yoga and not doing yoga. Okay, there is no connection between the person doing the yoga and not doing the yoga. Okay, they both are performing same. Maybe one is having active lifestyle and like another is like doing any other physical activity apart from yoga. Okay, so yoga have no effect on their body. Okay, so just this was a hypothetical condition. Okay, another is alternative hypothesis is it is designated as HA. Okay, and or H1 sometimes. So it is stated that there is the independent variable which is influenced by the dependent variable. Okay, it is influenced by the dependent variable. Two variables are being considered in question. One is dependent variable and another is independent variable. Okay, so when there is no association between them, its null hypothesis is true. But when there is association between them, or when they are dependent on each other, it is alternative hypothesis is true. Okay, like for example, athletes perform better on the field when they attend physiotherapy sessions. Okay, so this is a kind of one variable is associated with another variable. Okay, so if I go deep into that, say for example, how to start, what are the like steps of these? What are the steps? So first is what is my problem? First is problem. What is the problem in the question? Okay. Second thing is state whether this null hypothesis or alternative hypothesis is true. State the null or alternate hypothesis. Okay. Second is what? Choose the relevant test. Which test will you apply? Choose the relevant test and appropriate probability distribution. And appropriate probability distribution. Okay, choose the appropriate test and probability distribution. And while you are choosing the relevant test and appropriate probability distribution, in that case, we are changing the color. In that case, you have to determine the degrees of freedom. For degrees of freedom, I'm writing DF. Okay, and you have to decide whether it is one-tailed or two-tailed test. So decide if one-tailed or two-tailed. Okay, so first step is problem. What is our problem? Second is state the null or alternate hypothesis. The third is choose the relevant test and appropriate probability distribution. Next part is after choosing the appropriate probability distribution, choose the critical value. Like at what level of significance we have to find the value. Choose the critical value. And after choosing the critical value, we have to compare the calculated value with the expected value. So compare test statistic and critical value. Okay. After which, what you have to do now? Here, I'll tell you one thing more. So after which, you can accept the hypothesis or you can reject the hypothesis, right? After which you can accept the hypothesis or you can reject the hypothesis. So compare the test and critical value. So is your critical value falling in the is the test statistic falling in the critical region? Whether the test statistic fall in the critical region or not? Okay, if your value lies within the critical region or not. Okay, so if it is lying within the critical region, okay, then do not reject null. If yes, if it is lying, then do not reject null. Okay, and if it is not lying, if yes they are lying, then do not reject null, and if they are not lying, then you have to reject null. So we are not here saying about accepting the null hypothesis. We are not here concerned about accepting the alternate hypothesis. We are concerned here only about the rejecting null hypothesis or accepting the null, or rejecting or not rejecting the null hypothesis. We are concerned here about null hypothesis only. Okay, so if it's not lying within the critical region, then reject null. Okay, so understood. I will repeat the process once again to you. So here what happens? Ultimately, what was the conclusion? That we are rejecting the null or we are not rejecting the null. But when we are comparing the critical value here, choose the critical value, you have to determine the significance level. Whether you are trying to find out the significance level at 1% or 0.1% or 5%, so you have to determine the significance level first. Okay, and while you are comparing the test statistic with the critical value, here what you have to do, you have to compute relevant test statistic. That means which test statistic applies to your experiment. Whether you are doing t-test or ANOVA or chi-square test, depending on your test statistic, you have to find out the critical value. Now, whether the test statistic lies in the critical region, then you will you will not reject the null hypothesis. But if it does not lie within your critical region, then you have to reject the null hypothesis. Okay, so I repeat here once again that null hypothesis and the alternate hypothesis, how you will do the test. First is you have to define your problem. Second is state whether what is the null hypothesis here and what is the alternate hypothesis. Like for example, whether there is association between two variable or not, whether your mean, whether there is deviation from the mean value or not. So depending on that, you have to state the null or alternate hypothesis. You have to design it first. Then choose the relevant test and appropriate probability distribution. You have to determine the degree of freedom. You have to decide whether your one tail test or two tail test, whether your values should lie on the greater side or the lower side or both. Okay, then you have to choose the critical value. So this was number 3. Here I write this is number 4. Then compare the test statistic and the critical value, and lastly whether the value lies in the critical region or not. So this is the whole like the steps for hypothesis testing. So from the above chart, we understood that it is a null hypothesis which is being tested. Okay, moving to the next question. Students t-test was designed by. So it was designed by W.S. Gossett. Okay, let's study something about W.S. Gossett and students t-test. So first of all, what is students t-test? We already discussed a little about students t-test. What is students t-test? So students t-test, it is a technique for testing the theory of a mean of a sample. And when it is, so I'm just writing some keywords. Here the sample is normally distributed. Here the sample is normally distributed. Okay, and standard deviation is provided. Sorry, standard deviation is unknown. We don't know how much deviation is there. Standard deviation of population is unknown, and it is about testing the mean of the sample which is drawn from the population we are studying. Okay, so a scientist named W.S. Gossett, the full form is William Seeley Gossett. Okay, what he did, he created the students t-test and students t distribution in 1908. He did that. Okay, students t distribution or t-test. Okay, so I'm just telling you some theory about Gossett. So he worked at the Guinness Brewery in Dublin, and he discovered the small sample sizes which he came across during his job, and it made it impossible, where it was impossible to use the procedures which employs the big samples. Okay, so what he did, he invented students t-test, and here in the main thing is that his sample must be normally distributed. Okay, and the normal distribution here is used for the test involving the means of the sample with a size greater than 30. Okay, the normal distribution is typically used for the test here when the n is greater than 30, and here sample size will be less than 30. Okay, in Z statistics the sample size is greater than 30. Here I told wrong. Sample size would be less than 30 in case of t-test. It will be greater than 30 in case of z-test. Okay. And the formula of the student t-test is what? The formula is t is equals to x1 minus x2 by root under s square, which is standard deviation of the sample, that's n1, 1 by n1 plus 1 by n2. Here when sample sizes is different for two populations, then it is 1 by n1 plus 1 by n2. Okay, so some other things about t-test is paired t-test. Okay, paired t-test, two sample t-test, one sample t-test. What these are? What do you mean by these things? So, what is paired t-test first of all? What is paired t-test? So, paired t-test when two groups which are considered. So, uh, what do we understand about paired t-test? First of all, paired t-test and unpaired t-test. So, paired t-test is what? A test used to determine whether there is a significant difference between the means of two dependent samples. Whether there is difference, whether there is significant difference. So paired t-test is whether there is a significant difference between the means of two dependent samples. There is a significant difference between the means of two dependent t samples. Samples here are dependent. Okay. In case of unpaired t-test, here what we see that it compares the means of two samples. Here I have given the dot. That means up to here it is same. Whether there is significant difference between the means of two independent samples. Okay, independent, it will be unpaired t-test. When it is dependent, it will be paired t-test. Next, coming to two sample t-test and one sample t-test. So two sample t-test is what? It compares the sample means of same variable between two unrelated groups. So either the groups can be related or unrelated. Okay, so two types of two sample t-test are there. What are the two types? One is two sample independent t-test. So I'm writing here it in the next slide. Two sample t-test. One is two sample independent t-test and two sample dependent t-test. So when it is between the related groups, same variable between two related groups, okay, it compares the sample means between two related groups. Variable is same, okay, and when the groups are unrelated, then the sample mean for the same variable is compared between two unrelated groups. Then it is independent two sample t-test. So here what we see in two sample t-test, it compares the sample means of the same variable. Sample means are being compared of the same variable between two either unrelated groups or related groups. If it is unrelated group, say for example male or female, but when it is related group, what it can be? It can be, say for example, before or after. For related one. So here I write for dependent one example related groups means before and after, and in case of this unrelated group, say for example male and female. So these are unrelated. Before and after are related. Okay. And one sample t-test is what? It compares the sample mean to a population mean. So you have to understand all these. Next question is match the items of list 1 with list 2. Z test, chi-square test, F test. So now we all know Z test is what? Z test is testing the goodness of fit is what? It is chi-square test. So A is 2. Next is testing the significance of the difference among the average performance of more than two sample groups. When it is more than two sample groups, it is what? It is F test. Okay. Third is testing the significance of the difference between the average performance of two sample groups. Large size sample when it is there, it is Z test. See number 1. So a statistical test is what? Okay, statistical tests are used for hypothesis testing. So goodness of fit we have already discussed. Goodness of fit is what? It is to determine if the sample test matches the population. Okay, so I would like to elaborate it once again. So the first part is goodness of fit. Which is used in chi-square test. Two types of tests are done in chi-square. One is test of association, second is goodness of fit. And goodness of fit, what is the role of the goodness of fit? So goodness of fit helps to determine if the sample matches the population. So it determines if a sample matches the population. Okay, so and what is chi-square test? A chi-square uh, test is for two independent variables. What is chi-square test? It is for independent variables. two independent variables, and what it is for, it compares two variables to check if the data fits. Okay, you have to check the value from the table whether the difference between the sample and the population is significant or not, whether the sample drawn is from the same population or not. Okay, and testing the significance. What is F test? F test when there are more than two sample groups. Okay, it tests the significance of difference among the average performance of more than two sample groups. Okay, and it is basically for the equality of the two population variance. I will not discuss that in detail now. And F test is what? F test is about what? So, when a researcher wants to test whether or not two independent samples two independent samples have been drawn from a normal population. Okay, so F test is what? I write here, two independent samples have been drawn from the normal population. Have been drawn from a normal population with same variability. Okay, when the variability is same, when the population is normally distributed, then F test is used, and the sample size should be more than two sample groups. Okay, what about Z test? When we do we use Z test? So when the two sample groups are there and large sized. Okay, here the sample size, sample mean, since it's about large size, population is being considered here. So here population mean and standard deviation must be known. Standard deviation, here I write population standard deviation must be known. Okay, another thing about Z test, it is used to validate a hypothesis. To to validate the hypothesis that the sample belongs. Here, what is the hypothesis in Z test? That the sample belongs to the population. To validate. What we validate in Z test? To validate sample belongs to the population. From it is withdrawn. Okay, its main point is when there is a large size groups or large size population is there, then we use that test. Otherwise, we use t test. Okay. Now coming to the last question, match list 1 with list 2. Okay. So question is summation of observed minus expected whole square by expected. This is chi-square test. Okay, where we use this formula. Next is 12 by n plus 1 summation of r1 square by n1 minus 3n plus 1. So where we use this in Kruskal's-Wallis test. Then it's x bar minus mu by standard error. So x bar minus u by standard error. Where do we use this? We use this in Z test. And SS, sum of square between by sum of square within, we use this in F test ANOVA. So let's discuss this in detail again. So let's discuss this Kruskal-Wallis test. So it's a non-parametric test. So what is a non-parametric test? A non-parametric test that when the data is not normally distributed, we have to use the non-parametric test. Okay. So in case of Kruskal-Wallis test, which is also said to be as H test. So what happens in this case? So whether or not the samples have the same group source as the origin. So whether the sample have same group origin or not, or same population or not, same group source as origin or not. Okay, so this is used to perform or to compare. Here what we use, compare the medians of more than two groups. Here the medians are used. Compare the medians of more than two groups. Okay, so in case of Kruskal-Wallis test, category at the category level when the measurement is taken, so it is very important for comparing three or more groups based on dependent variable. Okay, so by measuring at a category level, it is very important for comparing three or more groups based on a dependent variable. Okay, and this Kruskal-Wallis test is represented by a formula 12 by n plus 1 summation of r1 square by n1 minus 3n plus 1. Okay, here k is what? Here k is the number of comparisons which is employed. Okay, k is the number of comparisons comparison groups which is employed. So what is k here? K is the number of comparisons groups which are here employed, like 2 or 3. Next is n. Capital N is here what? So if there is capital N, we use its overall sample size, and N is what? Sample size for the ith category. Okay, and what is R? Ri, it is the sum of the ranks for the ith group. Okay, Ri is the sum of the ranks for the ith group. It is the sum of the ranks. And what is Ni? This Ni is the sum of sample size. It is the sample size. And what is this? It is sum of rank. Okay. So what we understood from the Kruskal-Wallis test, uh, it is comparing the medians of more than two groups. Always remember, it will be more than two groups. Okay, and it is comparing the median. So it is comparing the median, and there will be more than two groups. The formula is 12 by n plus 1 summation of ri by ni. R is sum of the rank and ni is the sample size. And here k, or it can be h, which is h also, sometimes they use h, which is number of comparison of the groups. So here one more thing I would like to add about the Kruskal-Wallis test, that this Kruskal-Wallis test is the non-parametric test. Okay, so if you remember that in case of parametric data, when we were comparing more than two groups, what was the parametric approach for comparing more than two groups? So parametric approach of Kruskal-Wallis test is what? Kruskal-Wallis test is what? I think you can answer it. What it will be? It will be ANOVA. Okay, so that's it for today. See you again. Thank you.